Hello?
Hello.
Hello?
Yeah, hello.
Welcome. So, the topic of today's talk is going to be the top 3 things you need to know about microservices. Who am I? My name is Darius Davis, cloud computing and diversity and tech advocate, lead engineer of the professional services team at Dialogue Tech. I'll get into a bit of what we do. And a monolith to microservices migration survivor. So basically at Dialogue Tech, I lead the professional services team. Primarily what we do at Dialogue Tech is we are a call tracking company. We do call analytics. So essentially we are helping businesses understand what drives phone calls to their business, in a nutshell. We provide different tooling to basically allow them to optimize their marketing strategies to basically continue to drive calls to their business. If that sounds interesting, I encourage you to check out dialoguetech.com, and then you are able to learn more. Personally, my team is responsible for building custom applications to bridge the gap in our services. Anything that cannot be done out of the box, my team will be engaged and we will build a custom solution for you. That means that we get to work on a lot of custom solutions. We get to work on a lot of unique projects, a lot of interesting things. And that kind of leads me into why I wrote this talk. So, what is this talk really about? It's going to be about microservices architecture, of course, and what you and your team should know about moving to microservices. So, at Dialogue Tech, while each project is built to basically custom tailor to a custom business's use case, we noticed that we were housing all of our code in the same environment. It was sharing the same resources, so the same code libraries, the same database, the same APIs. So really sharing the same resources, and we realized that this made it challenging for us to deploy services, to deploy new projects without interfering with other projects. So we began to question, should we continue using this paradigm? Obviously, if we're seeing problems, this is not a good thing to do if we're disrupting other services on deployment. So we began to think, should we begin to decouple our services? Should we begin to break our services into a microservices pattern? So I can see the pros and cons to both sides, and the conversations that we had as a team are what I'm going to talk about today. So what we're going to talk about is what every developer, project manager, or anyone who works with a development team should know about microservices before you get into it. Hello? So the first thing is, number one, what are microservices? So, in a nutshell, microservices are modular, independent services that have been broken up and can be developed and independently deployed without disrupting other services. In a nutshell, that's basically what microservices are. So it's basically you have one overarching service, you have one overarching product, but you've basically broken that product or those service or that main service into small modular services. And the great benefit is that it gives the owners of the service the autonomy to use whatever operating system they want, use whatever language they want, use whatever deployment strategy, deploy on whatever schedule you like, rather than having to adhere to the overarching deployment schedule. So just to make sure, has everybody in here worked with microservices in any? Okay. Has anyone in here worked with microservices? Okay, cool. So I like to think of it like this. I like to think of a mall. If you walk into a mall, you see multiple stores. You see all kind of venues. However, let's take a step back. What you'll notice is that each of those venues, they have their own strategy. Each store in a mall, they have their own inventory. They control their own staffing. They run their own business. However, they're a part of an overarching product. So that's the best comparison that I like to give for microservices is that microservices are part of an overarching service. However, they are broken out and they are responsible for their own duties. Now, without them, there would be no mall, if you think about that. So if there were no stores, there would be no mall. So if you think about, kind of use the analogy of stores as microservices and the mall as the overarching service, we'll be okay. Now, let's apply that to software, like an application like YouTube. If you've ever used YouTube, I'm pretty sure everybody in this room has used YouTube, you'll know that there is a service or there is a way for you to like videos, there's a way for you to comment on videos, there is a way for you to post videos and view them as well. Each of those are individual services of an overarching service, which is YouTube. So obviously without those services, without the ability to post videos, without the ability to view videos, without the ability to comment on them and socially interact, YouTube would not exist. So the interesting thing about YouTube is that when they are developing and when they are pushing out new code to production, they're not pushing out the entire YouTube environment every time they deploy. They are deploying small pieces of the service. They're deploying an update to their commenting system. They're deploying an update to their rating system or their search system. Like, how do you search for videos? That would be an independent service on its own. So, in computing, the benefit of microservices, though, is, you might start to think, why do we do this? So, the benefit of it is that multiple teams can work independently. So, on each of those services, you have multiple teams, and they can work independently. They can deploy on their own cadence. They can choose whatever operating system or language that they want to support their service. Hello. The idea of that is that this level of autonomy allows you to build faster and push new features to production a lot sooner. Rather than if you were a part of an overarching service, you have to wait for those other teams to be ready, make sure their code is QA'd, and you actually have to rely on them to make sure that your code is able to be compatible with theirs. It's very important to understand that microservices often work with event-driven architecture. There's no longer a single server waiting for instructions, but rather event-driven architecture means that you send an event to your service, and that service is going to respond, it's going to do the job, do the work, and it's going to go away. So that's where the slogan, "You get what you pay for," comes from. Well, you only pay for what you use. That's where that comes from. So, does everybody in here understand what microservices are?
Yeah. Yeah. That was a good analogy.
Okay. All right. So, yeah, this is a good point. This is a picture of what we want. So basically this shows what a monolithic application looks like before the transition into microservices. There's a singular queue here. However, what we've done here in the migration to microservices is we've broken this queue up into multiple modular entities. So basically this is what you want. You do not want this. You do not want to break things up and they're broken and they're not cohesive and everything is that. So I'll tell you why and how you don't want to get hit yet. So, all right. So number 2. The second thing that I want to talk to you guys about is that microservices are best for greenfield projects. And so I recommend that you get your hands dirty on new projects. Personally, I would not suggest diving into microservices for the first time on a new project. On an existing project. So what I've seen a lot of companies attempt, a lot of orgs, a lot of groups, they want to migrate their services migrate their monolithic application directly into microservices. They understand the pain, they see the benefit of microservices, but they're like, hey, let's break it up now, let's do it, let's get going. But I suggest, just technically speaking, any application can be broken into microservices. There's no application that I've ever, unless anybody wants to raise their hand and attest to that, but there's no application that cannot be broken into microservices. However, depending on how tightly coupled your code is, how tightly coupled those services are, will make it much more difficult. So going back to the example about YouTube, is if those services are very tightly coupled, let's say your service for sharing videos, your service for commenting on videos, your service for searching for videos, if those services are very tightly coupled, you're gonna have a much harder time breaking them out into microservices because of the shared responsibility. So when you're working with a project, when they're not so tightly coupled, you have the opportunity to break those projects out. Break those services out. So it's our job, though, as professionals to assess what the pros and cons are. To say, okay, is this worth the risk? Is this worth the potential downtime? Is this worth the cost? We'll get into that in a bit, but the cost of moving to microservices. And that's really one of the biggest reasons that people want to move to microservices is that they want to reduce costs. They want their services to be reusable. So, despite the buzz, in closing on this subject, is that there are a lot of existing applications out there that are not using microservices today. So there's a lot of buzz about microservices. Anyone who's a developer in 2019, I'm sure you've heard about it. You've heard about companies using it. You hear these great, nice, heartwarming stories about how we moved all of our services to moved all of our applications and broke them up into microservices. Notably Netflix, they had a nice blog post about how they moved everything to microservices and made it seem like it was a breeze. However, the thing is, Netflix is a lot bigger than most organizations. They're very large, they're able to put forth the funds, they're able to put forth the effort, and they have the time to basically build these services out. A lot of organizations don't have that. This can be a very expensive thing to do. And especially if you are attempting to move an existing application to microservices, you put a lot of risk at potential downtime, incorrect architecture. So there's a very specific skill set that it takes to correctly architect a microservices pattern. So, in a nutshell, absolutely, yes, it's definitely best for greenfield projects. However, there are exceptions. Like I said before, if your application is not tightly coupled together, you absolutely can break it into microservices. However, if your application is very tightly coupled together, like most applications in probably like the last decade have been built, they are built very tightly coupled together. It's hard to break them apart, or at least the business function. The importance of unification is the last thing I want to touch on for number 3 of microservices, of the important things that you need to know. So, does anyone in here know what polyglot is?
The person who speaks many languages?
Yes.
Or,
Yes, more specifically, yes, but you're both correct. So polyglot essentially means that you use multiple or you speak multiple languages. So in the programming world, when they say polyglot, that means that there are multiple programming languages, multiple thought processes and development methodologies in place. So that means that people are doing different things. So polyglot is actually promoted because it can open up staffing opportunities. For example, if you're just a complete Java shop, then you just have to find Java developers. However, if you're polyglot, you can leverage the talents of many different developers. You can use a Java developer, you can find a PHP developer, you can find someone who does JavaScript. However, polyglot can be dangerous. So, the important thing that I want to highlight in this slide is the importance of unification. Lack of unification can really hurt your overarching product and your team morale and many other things. It can damage a lot. So when your teams aren't unified, what do they become? Separated, siloed, they're kind of just off to themselves in the corner. So when we're working together and we're trying to build a product, I mean, don't we all need to be kind of together and cohesive? So the microservices basically is the opposite of that. It kind of encourages each team to be separate. It encourages each team to kind of shuffle off to their own corners and develop whatever they're responsible for developing. So the services that each team builds, they can become esoteric. They can become just knowledge that they only know, and it's not being shared. So this is just something to be aware of. Beware of lack of unification. You might be saying, hey, I thought that's what microservices was all about. I thought everybody was supposed to be independent and everybody was supposed to just be separate and do their own thing. However, it is. However, in the early stages, that might be fine. But if you think about as the service matures, as the overarching product matures, and as things begin to progress, that becomes hard to maintain. Just think if on one of those teams, let's say one of the key members of that team decides to pursue another opportunity. Now you are in a position where you're attempting to recruit for something that you may not even be very familiar with, because you've given the autonomy to these teams to build whatever they want to build. Has anyone in here ever heard of Falcon PHP? Falcon. Just a name, a really random name, but it is a PHP framework. In my past, I worked with a developer who used that, and I had no idea what it was. So when I got into the code base, being a PHP developer, I assumed that I would be able to just take it on and pick it up. However, there was a lot more in Falcon PHP that honestly didn't have anything to do with PHP. Falcon PHP has some C's, like some compiling components and different things that you can add to that service and whatnot. So basically, there's a couple different moving pieces with Falcon PHP. So just a quick example of how, you may think that, all right, I'm hiring a PHP developer, he should be able to handle this. You don't know the underlying technology. You don't necessarily understand it, because you've given the autonomy to these teams to develop it and do their own thing, because that's basically what microservices is about. But you have to have boundaries. You have to have standards. So the interesting thing too is to remember that when you're developing a microservice and you have different teams that are developing these services, is that each service is technically a black box to each other. Everybody knows what a black box is, right? Basically, it's a service, you don't know what's going on in it. All you know is you put data into it, it comes out, and that's how, you know how the data comes out, and you know how the data is supposed to go in. It's a completely black box. You do not know what's going on inside. However, the problem is that I'm trying to emphasize here is that when you don't know what these services are doing internally, it can be very hard to implement them sometimes without the proper documentation, without the proper unification. So, has anyone ever heard of the Tower of Babel story? It's a biblical story. It's called the Tower of Babel. In a nutshell, it was basically a bunch of folks attempting to build a tower to heaven. And basically what happened was that God did not want them to build this tower to heaven, and he changed their language so that they could not continue building that tower. They couldn't communicate with each other, so they couldn't progress that tower. They couldn't progress their construction. So I apply that a lot to microservices and how development teams work, because as these teams mature, as the product matures, you eventually start to notice that these developers, they can't understand each other. There is an immense roadblock in communication between developers. So if you start to think, if one service is speaking Java, this one's speaking PHP, this one's speaking Go, and this one's speaking JavaScript, basically very different languages, how can they understand each other without a common translation layer? Without a common layer of translation, how do you understand each other? So imagine, each one in this room, you've built a company, you've hired developers, and you've kind of segmented them off into different products to build different job functions, different functionality for the business. So how do you ensure that their services are able to communicate with each other? Okay. So well, let me caveat that real quick. So some folks may say, this is great. All right, I don't want them to communicate with each other. I want them to just build their own service and just tell us how to implement it. However, people love to oversimplify software. They love that. So the cool thing is that if you think about it, when you change the implementation of the software, you're going to have to involve other teams anyway. There's no way around that. You cannot change the implementation of software and not involve anyone. I've tried to do it before, it doesn't work. Basically, I try to send out a Google Doc or some type of documentation on what has changed, a change log. However you do it, the best thing to do is to get in a meeting, to meet with folks, talk to them face to face, and sit down, do a demo of what you've changed. So, one thing I want to do is I want to ask the audience, just everyone, what do you guys think about microservices? What is the thought? Does anyone have any companies that are currently looking at microservices? Do you all have a monolithic application that you're looking to break up and separate responsibility? What does that look like for you guys?
I can give one example of an application that I operate. I work with the developers that develop it. And we do use microservices in it specifically for some of the front-end elements, some of the back-end elements. I mean, maybe what those elements do, you might call it bigger than what some people might call it a microservice. Mm-hmm. But one problem that we have is sort of a disconnected error status between the front end and the back end, so that the front end, which is a Rails application, will be up and running, and it's not able to talk to some of the database structures in the back. Application's up and running, it's fine, it's beautiful, people try to log in, it's like error, 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 but the front end's like, hey, everything's working as far as I'm concerned, whereas on the back end of the database is screaming.
Now, would you say that was miscommunication between the teams that were developing the front-end service and the back-end service?
Well, it's the same team.
Oh, it's the same team,
yeah.
Okay.
Different developers, but yeah, it's the same team.
Gotcha.
Still siloed nonetheless.
Right, but between those two different, even though they are the same team, but between those two different groups, was there miscommunication?
Yeah, I believe so. Yeah.
So, I mean, that's basically what I'm trying to highlight in this slide here is that if you do choose to break your application into microservices, into modular services, you have to make sure that these teams are communicating. Because what you'll end up with is you'll end up with services scattered, very fragmented, and no one is understanding what each other is doing. You've all heard the saying, left hand doesn't know what the right hand is doing. Same thing. So yeah, another thing is, have you guys had any challenges in, I'd say, I'm assuming most folks in here work with tech, work in tech? Have you had any challenges with, I'd say, a larger monolithic service? Like, have you, let's see, let me throw one out there. Oh, the first example, deploying an update and accidentally breaking something else.
Yeah.
Does anyone ever?
Yeah.
Why did that happen?
Well, the application was so big that it takes a lot of time to just test every aspect of it. And there's times when, code that you push for one thing definitely just breaks something that was totally unrelated. That QA or, the engineer didn't test.
Something very unrelated, right?
Yeah.
Exactly. So that's why people want to move their services to microservices. Because, hey, it can be dangerous. I mean, it can be very bad, especially if you have like any holes in your QA process. Or like you say, like if your application is just so large and you just don't have either the resources or just, you don't know what you don't know. So if you miss any part of that QA process, you put yourself, put your company, the entire application product at risk of being disrupted. So, we give an outro and we're gonna open it up to some more questions. So, just to summarize kind of what I've talked about here. Microservices, it's a great pattern to decouple your application, especially if you've built it in a way that everything kind of just intersects with each other, everything touches each other. It's a great way to ship new features faster. Anyone in here who is in leadership or you've requested, or project management, you've requested a feature and you're wondering, well, hey, that's a small change. Why did it take so long for you to ship that? Why does it take so long for you to do that? It's because the QA process probably takes so long. The actual code deployment process may take so long because oftentimes they're deploying a lot more than just that one feature. So that will alleviate that. And also it adds flexibility to development teams. You're able to hire multiple developers. You're able to recruit various different people from different backgrounds rather than, I'd say, up until microservices became popular. I'd say it's not a new pattern. It's nothing new that's recently came out, but it has gotten a lot of buzz because of the availability of infrastructure. You have cloud vendors like AWS, you have Google Cloud, you have Azure, Microsoft. They give you the tooling to basically get this stuff up and running a lot faster than it was 10 years ago. So it has developed a lot of flexibility to your teams. You're able to, definitely hire a much broader group of people. And then the second point is, really quickly, does anyone know what event-driven architecture is? I touched on it briefly. So, microservices is powered by event-driven architecture. So earlier in the example that I provided was, it's no longer just a server sitting idle waiting for a command. It's no longer a server just sitting idle waiting for you to tell it to do something. But the idea of microservices is that you have this service that is not idle, but ready to be invoked. So essentially, you have an event. Let's say an email comes in and let's say an order comes in. Let's say you're running a website, you're Nike. A shoe order comes in and you want to send out a confirmation email. So basically you have two services there. You have your order service, then you have your email service. So essentially what happens is that order comes in. Once that customer places their order and that order system gets the message from the payment service. So that's another third service. So you've got the payment service that sends a message to the order service. And then the order service will send a message to the email service to send out an order confirmation to the client. That is event-driven architecture. So these are events. So the first event was the payment. The second event was the actual order. The third event would be the actual email confirmation that goes out to the client. That is event-driven architecture. And that is a paradigm that we're moving towards, in the tech world, but I'd say in the last couple decades, it hasn't really been taken advantage of. Mainly because we didn't have the infrastructure to really do it. And now that we have these vendors such as AWS, Google, Microsoft, we're able to do those things. So if it's correctly implemented, it will save you a ton of money because you're only paying for what you use. You're not paying for a server to sit there and basically wait for someone to place an order or wait to send an email. The days of email servers are over. I definitely remember those days. Does anybody remember email servers? Postfix, configure email servers. Those days are over. I haven't touched an email server config in years. So those days are over. We have services that will take care of that for us.
What's the overlap between, say, the event-driven architecture and serverless? Because then, that's like the next level of not even, just using the server as needed.
Right, so I'd say event-driven architecture is basically the methodology. Serverless itself is the methodology of the infrastructure. So event-driven architecture is the development methodology, whereas serverless is kind of the infrastructure methodology. So you can have event-driven architecture with non-serverless infrastructure. You can have, literally, you can set up a server here, you can set up a server here in your closet and have event-driven architecture. You can have an event triggered from this server that triggers this server. Now, serverless is basically literally what they call serverless, as in everything is in the cloud. There are still servers, that they like to call it serverless, but everything is in the cloud, hosted in a data center far away from you. So the overlap is that you can use event-driven architecture in a serverless application.
Don't you almost have to? Because then something has to kick off, to fire something off.
So I will debate that. I don't think you have to. You do not need to use event-driven architecture because, as I'm highlighting here, there are ways to do this very wrong. Whereas it's not completely event-driven. Whereas you can have a service basically that isn't event-driven that could be polling another service. For example, let's say looking for results. That's not really event-driven. That's a polling architecture. So let's say we're polling Nike's API for the latest shoe or something, or like we're polling for like a change in price on like a particular product or something like that. That isn't necessarily event-driven architecture. That's not like a publish, subscribe, pub sub architecture because Nike isn't going to notify you when that happens. You have to poll their service, you have to poll their website, you have to scrape their website in order to see that change. So basically what I'm getting at there is that it's not always, just because you're using serverless, you're not necessarily using event-driven architecture. There are other ways to build software other than event-driven architecture, and often I see it a lot with serverless. Have you seen anything different?
No, I was just, thinking how that.
Okay. Just curious. Hey, I'm here to learn as well. If you've seen anything different, definitely. With serverless, people can do a ton of things. Were you referring to the serverless framework?
Yeah, but it's just, something has to happen.
Right.
In other words, so one of the problems with serverless, for example, is that you have to have a fire up time.
Mhm.
So you sometimes have to have something as simple as like a cron job to keep it awake.
Right.
You know, because it's sitting there idle for so
Exactly.
long that then your thing is slow. So you got this fancy thing, but it's slow because it's the first time it's been fired up in 3 days or something like that.
Yeah. That's another interesting thing too about moving to microservices, because especially if you lock yourself in with a vendor like AWS, and they've recently fixed this. Anyone who's familiar with AWS Lambda, common component for building microservices, you'll know that they had an issue with cold starts. Basically, you want to fire up your service, but it takes time for it to get warmed up. So they've recently fixed this, but it was a problem for many years. So basically what would happen is your event would hit your service, and it would take up to like 15 seconds or so for it to warm up and actually kick off and do what it was supposed to do. You know, for a lot of people, for highly available systems, this was not good. They did not like that. You know, so AWS did eventually address that. I can provide some information on that as well. But AWS did eventually address that, and now the cold starts are gone. Lambda's fire up almost instantly now. And that happened, I'd say, in the last couple of months. So, yeah, and the other thing too, just to know about the second bullet point, is that it can definitely increase your dev and your operational costs. If you think about it, if you don't architect these things correctly, you can end up spending more in log aggregation. You can end up spending more in staff, because again, it takes a special skill set to be able to architect this pattern correctly. So if you're a beginner, you're just getting your feet wet, trying to get your hands dirty. If you don't necessarily have the skill set yet, not saying that this stuff is like super hard to learn, but it would definitely increase a cost somewhere, whether it's operational, security, it could be anything. Basically, in order to adopt this architecture, there will be some sacrifices that would need to be made, usually financially. Whether that's consulting or bringing someone in to help you out. So now that we know, microservices allows you to decouple your applications, you can build much more agile and flexible teams. They can use their own languages and whatnot, and we kind of understand the pitfalls. We understand where it can go wrong if we're not doing it properly. The last thing I want to highlight is this third bullet point, kind of my favorite one, is the unification amongst your dev teams is extremely important. If your teams are completely separate, siloed, no one knows what each other is doing, like you guys don't have regular meetings, or kind of like at Dialogue Tech, we have like a 2-week scrums, like where everybody comes together and we understand what everybody is doing amongst development teams. So the thing I just want to say is definitely make sure that you're talking to your neighbors, your fellow developers and whatnot. Don't be the one who just kind of like walks past everybody and just like ask, just see like what are they doing. I definitely think that that's a good way, rather than having structured standard meetings. But just being nice to everyone and just talking. I think that's a good way to understand what everybody's doing. So one cool thing that I want to talk about is Conway's Law. It's the last thing. So basically there was this guy named Melvin Conway. Basically he was a computer scientist from like the 60s. And he came up with the idea, well not the idea, but he basically stated that software will only be as great as the communication of its authors. You guys agree with that? So basically that means that if the communication between its authors are very poor, the authors of the software, if no one is really like talking, if everybody just kind of just does their own thing, they push it to production and it's just like whatever, shrug their shoulders, it's like the product is gonna suck. It's not gonna be great. You know, you're gonna have problems, you're gonna have outages, you're gonna have bugs, you're gonna have, you know, people who don't like each other, you know, because they're gonna play the blame game. They're gonna say like, oh, that team over there, they shouldn't have did that and we didn't know what they were doing, and you know, it's like really, so that's something you want to avoid. You don't want that in your workplace. You do not want that in your everyday work life. So definitely listen to what Mr. Conway says, and he says that definitely improve the communication between your authors, and that will definitely improve your product. And basically, signing on, connect with me, connect with Dee. This is my Twitter, YouTube channel. I post various different videos discussing tech topics. Feel free to subscribe, my LinkedIn, as well as my email. And I will make the slides available on some platform. Or you can reach out to me and I will provide them to you. That's my email. So now I'm just gonna open it up for any questions if anybody has them about microservices.
I do.
Michael?
So the first thing I would ask is one, thank you for giving that talk. I've definitely been educated in regards to microservices.
Okay,
That's
cool.
been awesome.
Cool.
In what instance would a organization not want to migrate an application to microservices?
Good question. So, in the instance that you would not want to, I would say is that if your service is not reusable, if your service is not implemented by multiple teams, microservices can be an overkill solution for, you know, many teams. So, let's say, you know, the example I gave about YouTube.
Yeah.
You know, you got your service for commenting, and sharing, and viewing and searching. If those services were not reusable by anything else in the YouTube ecosystem, would it really be worth it?
Yeah.
And like I highlighted earlier, the cost of moving to microservices, the cost of hiring the staff to help you properly architect it, consulting with different contractors to help you properly architect this, the time that it takes to break a monolithic application into microservices, it may not be worth it for you. It might be just worth keeping your service or your monolithic application in its own realm. And that's why I recommended in slide 2 is that, you know, it's best for greenfield projects. For new projects, absolutely. I would encourage that you take a step towards microservices. For existing applications, if everything is very tightly coupled, it's going to increase the difficulty of breaking those out.
And that's actually another question I was going to ask you too. Is, you know, when you do have applications that are very tightly coupled, in the instance that you recognize that it should be migrated to microservices instead, what are some best practices that you can kind of give us in regards to migrating those tightly coupled applitions
Gotcha.
to microservices?
So that's worst case scenario. Like when
Yeah,
you have
yeah.
a very tightly coupled application,
Yeah.
you want to move it to microservices. The best thing to start doing is getting into the code, documenting it, documenting, understanding what each function of this application is doing, and then that will allow you to begin to separate the functions of the application.
Gotcha.
You can begin to say, hey, okay, I know this part of the application is doing email. Right? That's all it's doing is email. You're able to separate that out and then send a message from, like the original Nike example, someone places an order, send a message to that email service and send out the emails. You know, so you can identify low-hanging fruit. You know, you can identify very, you know, easy to tackle things. So, you know, that's one right there, email. That's something that you can perhaps, depending on your application, easily separate out. Did I answer your question?
Yeah, no, it did, and it kind of triggered one more question in my mind. I don't want to hog the questions.
Go ahead.
Well, this is my last question, but you know, I'm a technical project manager. I'm actually a technical solutions engineer. So, I work very closely with multiple teams within our organization as well. And one thing to your point where you're saying, you know, where things are, each microservice is created within their own unique language. What are some best practices? I know you kind of explained it a little bit at the end, but what are some best practices in regards to making sure that every team is on the same page, that they're communicating and that they are knowing what's happening within their specific microservice?
Great question. Yeah, I would say definitely having regular meetings, having regular just sit downs, talks. Like I said, even at DT, you know, we have like the bi-weekly scrum of scrums,
Yep.
basically where every development team gets together and talks about what they're building, what they're doing, and what changes they've made. You know, we have the camp meetings. You know, you have those. Basically, you know, having those on a regular cadence will definitely help protect you against, you know, teams going rogue and building things that perhaps should not be built. Correct.
I got you.
Yes.
But even with that, I mean, I know you're communicating, perhaps it's verbally, perhaps it's written. What about documenting the interfaces between the service? What's a good method for that? So that, you know, I'm developing my service over here, you know, the purchasing service, for example. I know it's gonna need to talk to the email service. What's the best way to document what I'm providing, what the email service is expecting, and how those two are gonna communicate?
Got it. Yeah, so whether it is the role of the developer, I think it should be a group effort because I'm all about talking with my fellow devs, but it could be the project manager's responsibility to create network diagrams. Create a diagram of basically how this team service interacts with this team service. What are the dependencies of, or even like a product manager. I mean, like, well, what are the dependencies of my product? You know, I have a video streaming platform, and I have dependencies from other teams that I need. That should be diagrammed and definitely documented in some platform. So I like network diagrams, I like pictures. So I like seeing, you know, the lines between all the different components and whatnot. And I think that is a big help because it's visual, you can see it. And the sooner you get that in place, the better, rather than, you know, how many days after release, then we start putting that together. No, I think that should be put in place prior to release, like in the scoping phases even, like how am I gonna interact with your dependency? How am I gonna interact with your service? So I'm building Darius's service, you got Michael. I knew it. I had to make sure. Okay, so we got Michael's service. Basically, if I knew I needed to involve a dependency from your service, I'm gonna loop you in. Smart. I'm gonna loop you in early, and I'm gonna begin getting those diagrams mapped out. I'm gonna begin getting that documentation written and get it into whatever platform where it can be commonly shared. It could be a simple Google Doc. Yeah, just some kind of common documentation where everybody can look at it and the people after us that inherit the code can look at it. Yes.
In our system, one of the situations is mobile apps talk to an API and get most of their data through there, so service-ish. But what we found was that the mobile QA team ended up creating an automated test suite to make sure that the API was delivering what was expected. So although it wasn't their ownership technically, they didn't own the API, they found that the best way to make sure that any changes that the API team had done didn't have dramatic negative impacts was to incorporate an automated test suite. On their end, they just said, look, I send you X, you give me Y. That's what I'm expecting.
Right.
Boom. If that ever changes, then alarm bells go off, and then they can call the API team and say, hey, you broke something, something's up, whatever, with the latest version. And so that helped a lot. They also did, to some degree, they data drive or code drive the documentation of the API calls, so that they don't have to rely on human beings to do a lot of updates to them. Because as soon as you write a document, it's going to be out of date, right? By the time you save, something's changed.
Yeah.
So code driving documentation and then relying on automated test suites helps a lot because it ensures you're backward compatible. The other thing that we do is the API has a version, and so because we're dealing with mobile apps, Once they're out in the wild, you can't update them. So those apps know what version of the API they can talk to, and when they make a server request, the version number is part of that request, so that then you know what they need, you know what they're expecting, right? And then as you change the API, if you're doing things that aren't backward compatible, you up the version number. So then you know, like, okay, this is now version 53, 56, whatever. So
Right.
then the earlier apps probably can't talk to that later API version, or the parameters are a little different. So those things help to create some guardrails and to make the safety around those separate services talking to each other.
Yeah.
You can also have a ridiculously monolithic Rails app that no one, like, everyone keeps saying the word, we should break this up, and everybody's like, no.
Yeah.
It's not happening.
Because, I mean, it could take a lot of time. It could be expensive, yeah.
It's gonna be a big deal, yeah. It's
Yeah.
gonna be a big deal.
Yeah.
But in the meantime, we have a lot of pains because of it, but so far, the potential gains aren't outweighing it.
Have you guys taken a look at, do you have any low-hanging fruit that you can potentially break out? Like maybe like a smaller business function that you can break out of that Rails app?
Thankfully for me, I switched away from managing that team, so.
Okay. Not my problem, right? Yeah, nice.
Now I'm doing project management, but, yeah, I mean, there are some aspects of the app, there's some aspects of it that are somewhat separated, and the first thing that they're gonna try to do is to switch the web app to using an API along the lines of what the mobile apps use. So that all three of the platforms are referencing the same API, because then you're centralizing the data access for most of the application.
Gotcha.
So that'll help. That'll be a big deal.
Yeah, absolutely.
And at least with the web, if we update the web code, we don't have to worry about older versions flying around. So that'll, simplify that a little bit. But yeah, it's a big deal.
Gotcha.
It's a big choice to try to break up the big app.
Yeah, and I agree with the earlier point you said about the guardrails. So, yeah, definitely automated test suites to ensure that you're getting back what you expect. Like I was saying earlier with the different services is that, everybody is developing something different. And once the implementation of the service changes, and I've actually, unfortunately, ran into this before, but the implementation of the service may change, the format of the response may change, and that can cause basically a domino effect of things breaking. So, yeah,
If
definitely.
you're sending different data back, if you change the business rules around what populates a certain field in the response on the API call, then you can break the application. If the application isn't coded to be fault tolerant, then it can't handle the wrong data in that particular field.
Correct.
You're looking for a name, and or you're looking for like a content type, and there's 5 content types, and nobody bothered to code a default in the app. And then there's a 6th content type that suddenly starts getting passed down, and the app breaks because it doesn't know what to do with that 6th content type.
Either breaks or just drops it on the floor, yeah.
Or it drops, I mean, in the best case, drop it on the floor, worst case, it breaks.
Breaks, yeah.
So, yeah, there's cases where the fields and the format and all of the parameters didn't change, but the actual values changed because business logic changes and you're breaking shit. So, yeah, automated testing is a good bet.
Absolutely, yeah. Just integration testing, unit testing, great things to do, definitely to ensure that your applications are not breaking, especially when you are interacting with other third-party services or things built from internal teams. Any other questions on microservices? Anyone working on any personal projects or any projects for work that perhaps are causing problems? Kind of like the problems we described? Such as you deploy one thing and it breaks like all these things?
I've run into that before.
Yeah, or perhaps you have a team or you have multiple teams and they're all coding in different languages. And you want to know how can I interface with those teams?
So something I'm curious about, the term microservices, as you say, is floating around a lot in the last couple of years.
Yep.
To what degree is there a formalized definition of what constitutes a microservice? I mean, there's the concept of APIs has existed for a long time. Making requests across services existed for decades.
Yep.
So, like, when do you get to call it a microservice? I guess is my curiosity.
So, in my opinion, a microservice, and again, it's very opinionated. In my opinion, microservice is a service that can be independently developed can be deployed independently without interfering with anything else. I mean, literally that one liner right there is what a microservice is to me. It means I can deploy it, I can work on it, and it's not gonna mess with anything else. You don't need to know about it. I can build it however I want, and I will give you the documentation on how to interface with it. This is how you can use the service. Don't worry about how I'm deploying it, when I deploy it. Here's your documentation, here's your versioning, that's it. And
I was just gonna say, so it's almost like feature level deployments, more or less, am I right? Or
yeah, I mean, you're deploying an independent feature of an application. So let's say I'm YouTube. I want to make an update to my commenting system. I want to be able to share emojis or GIFs or something like that. So I want to make an update to that service. But I don't want to interfere with the search. I don't want to interfere with streaming. I don't want to break something else. I'll only update that one service. Or perhaps the sharing service. You want to share videos with folks. I want to update that particular service. I don't want to touch anything else. To me, that is microservice architecture.
Hey, what would you consider the best tool for testing these services?
Humans? No, seriously. Well, the best tool I would say it would be automated test suites, to be able to test them, to be able to make sure that they are doing what they're doing. So much to the point, what's your name? Alex. What Alex said was basically, when you're expecting a certain result from a service, you can set up automated test suites on your side, or even the developer, he can set up those test suites on his side as a part of his development to ensure that those services are inputting the data that correctly that you want to send to those services. Because the service may respond, it might bark and just say like, hey, what is this you're sending me? Make sure that that service is accepting the data. So it's almost like an integration test, an end-to-end test of that service. And then when that service responds back to you, you want to make sure that it's giving you the response you expect and not telling you something completely different. So it's almost about knowing the service that you're working with. I'm sure many of us have worked with services that it threw like an unexpected response. It returned something you've never seen before. You're like, what is this? My application wasn't expecting this. So it's all about knowing the service that you're working with and knowing the documentation and making sure that your code is prepared and has a fail route, basically. If it does receive something unexpected, it doesn't throw a hard exception back. It fails gracefully and logs that exception and sends you an alarm or something at hopefully not at 4 a.m. or something.
Like SOAP UI or something like that.
Well, what do you mean?
Like SOAP UI is a service we use, it's an API call, is what it is.
Right, so that's a program, correct?
Yeah.
So yeah, you can, well now that's kind of manual though, right?
That's manual.
That's very manual. So I'm thinking of kind of along the lines of like Alex, like automated testing. Obviously you can have CI, CD pipelines that when you actually deploy the code, it tests it for you. And it basically builds an environment, runs the code for you, and gives you like a passing test, which is beautiful. Now, if you want to test it basically manually, yeah, using something like SOAP UI, where basically you can throw an API request at some endpoint, see what the response is, put in your input, make sure that it's being accepted. Yeah, you absolutely can test those things manually. I was joking earlier about like humans, but yeah, I mean, that would be the human manual way of testing it. Whether it's SOAP UI, Postman, however, yeah, absolutely. Did I answer your question?
Yeah.
Okay, good. All right, what else?
thanks, Paris.
Cool.
Thanks.